Hi everyone, Aaron here. I'll admit it, data digitization is not exactly the most thrilling activity, but it is crucial to science. Without having data well organized and accessible to a computer, modern science has nothing to work with. That's why here at Enki, we are doing our best to make data digitization as streamlined and painless as possible. In this video, I'm going to give an overview of the primary dataset for Enki, which is the phase reaction data file. To be concrete, I will go over a filled-in example that I performed for the Holdaway 1971 paper, which you can see right here, which was focused on the stability of aluminosilicates. If you haven't already watched it, you should watch our previous video on how to use the data template tool in order to construct the Excel data file specific to your study. We'll begin by looking at the tabs specific for the phase reaction dataset type. You can see the first few tabs are actually quite simple. The reference tab stores information about the publication that you are digitizing, things like the authors, the title, the journal, and so forth. The publication ID can be found on the wiki available on the GitLab site. Just click on the link on the screen. The Notes tab is just human readable notes in any format you wish, storing notes about the choices that you had to make in order to digitize the file. The Phase Symbols tab is automatically constructed by the Data Template tool, and it provides the valid phase symbols for each phase appearing in the experiment. The Starter Phase tab defines the chemical information about each phase that is used in the experiment. At this point, I want to emphasize the difference between a phase and a sample. A phase is the ideal theoretical thing that is undergoing a reaction. So for instance, if we have andalusite, the phase symbol is the standard symbol AND, and this refers to a theoretical andalusite that's in equilibrium and behaving perfectly. The sample is the specific actual sample that was actually placed into your experimental chamber. And it will have a non-ideal chemistry, which is hopefully measured and stored in the starter phase tab. You need to provide a sample ID that is unique for each individual sample. If sample IDs are not provided in the publication, I suggest using the phase symbol followed by either a number or letter referring to that individual sample. So for this study, you can see that there are actually 4 different sillimanite samples that were used in different runs. And so each of them has its own unique sample ID. After that, you need to provide the formula for each of these phases, at least the idealized formula using the Berman format. The source pub ID column stores information about the source publication where reproduced data can be found. Any data found in your publication needs to appear somewhere in one of the Enki data files. However, some of that data may actually be reproduced or copied from previous publications. When that's the case, you need to indicate that in the source pub ID column. Fill out that column with the official publication ID of the source where that data came from. This is crucial for ensuring that we don't double or triple count pieces of data when we do large-scale calibrations. The Notes column, of course, contains important information for human users about each individual sample. In this case, you can see that there are notes concerning whether sillimanite contains the fibrous form fibrillite or not, because it has an important effect on the reaction boundary. Many different tabs contain the columns table num, figure num, and page num, which allow us to simply and easily find where you found this data in the original publication. You have to indicate whether the sample is synthetic or not. This uses the standard yes, no, maybe format. And also whether the sample contains any contaminant phases. This is crucial, especially if there are any phases that can bias the reaction. In this case, you can see that it contains the 30 and 10 volume percent of fibrillite, which we will find biases the reaction. After that, you can define the chemistry using the chemistry columns. Detailed information about how to fill out the chemistry columns is found in our chemistry video linked on the screen now. The experimental conditions tab contains all of the information about the experimental setup and the conditions under which it was performed. So unlike the starter phase tab, which only has probably a few to maybe a dozen different rows representing each individual phase or sample, the experimental conditions tab will have dozens to maybe even hundreds of rows, each for an individual experimental run. The index is just a number that is counting up by 1 each time, uniquely identifying each experiment. And the run ID is a specific identifier that meaningfully indicates which run you are referring to. If found in the publication, you should use the identifications provided there. But otherwise, you should make up names that are meaningful to you. In this case, no run IDs were provided in the publication, and so I needed to make up meaningful names myself. AK refers to the fact that it's andalusite and kyanite. Xtol refers to the fact that it's a single crystal measurement. 2.4 is the number of kilobars, and 1, 2, 3, 4, 5 is the particular run at those conditions. You also have to fill out the lab ID, which gives the identification of the laboratory where the experiments were performed. You can find the list of lab IDs on the wiki page. And again, source pub ID if these are repeated data from a previous publication. We also have a notes column as per usual. Please use it if anything strange or out of the ordinary occurred in that particular run. The trust conditions tab indicates whether or not the conditions reported in this tab are trustworthy. And it follows the standard yes, no, maybe format. Things that might make the conditions untrustworthy are, for instance, if a capsule did not remain sealed during an experiment, or if the heater cut out partway through the run, or if the temperature control or temperature readout failed during the run. All of these would make the experiment untrustworthy, and so you should choose either maybe or no in that case, and then describe it in the notes column. We have the standard table, figure, and page number columns. The device and container columns store information about the experimental device that was used and about the capsule material that was used. In this case, they used multiple capsule materials and didn't say when they used which one, so I provide a list that is separated by a semicolon. Container size, when available, is useful information. And you also need to provide information about what pressure medium was used, as well as the pressure measurement method. Both of these can be selected from a standard pull-down menu. Likewise, the temperature measurement method is very important. There are multiple different types of thermocouples available, and you need to define, if they used a thermocouple, which thermocouple type was used. In this case, a Chromel-Alumel thermocouple, or type K thermocouple, was used. When available, the temperature measurement sample location should be provided. It can either be adjacent to the sample, touching, or separated. And likewise, if available, the heating location should be provided, whether it's axial, center, or off-axis. Finally, we come to the type of data that should be provided in every single paper, and those are the pressure and the temperature at which the measurement was taken. So the pressure and the temperature can be defined in a range of units, kilobars, GPa, and so forth, Celsius or Kelvin. And also, the uncertainties or error on these measurements can be provided either as a percentage or fractional error or as an absolute error. So in this case, they reported 1.5% errors on the pressure, but 5-degree errors on the temperature. And therefore, we use percent for the pressure error column and absolute for the temperature error column. We also need to report whether the oxygen fugacity in the experiment was buffered or unbuffered. If the oxygen fugacity is buffered, then you need to select which is the reference buffer that was used. In this case, it was a hematite-magnetite buffer, and you can see descriptions of those in the tooltip. Because these are buffered experiments, the FO2 offset will be 0. If it is not a buffered experiment, but they use a model to obtain an approximate FO2, you should put that value in here. The units are the standard log units of log bars. And if provided, FO2 errors should also be included. The equilibration time is really, really important to provide. That can be given either as days, minutes, seconds, hours, or whatever, and that defines how long the experimental run lasted and gives an indication of how much kinetic effects are important. We really do need that information for the calibration. The sample material tab is fairly straightforward. You repeat the index and run ID for each run. So this is a duplicate of the experimental conditions tab. And additionally, you provide the information about the sample mixture. What things were put into the cell, what phases were mixed together in order to actually create the sample for that particular run. You can provide a numerical indication of the mixture by preceding each sample ID, for instance, AND1 or Chi1, with a number, in this case 50. If you are unsure of the exact proportions, you can use a tilde to represent roughly. Each of these should be separated by a space and a plus sign. If it is totally unknown the quantity of each thing, you just know that it went in there, then you can not use a number. So in this case, we know that it was 74 weight percent Andalusite 1, 1 weight percent Kyanite 1, and the rest is quartz and corundum, but we don't know how much, so they include no numbers. And again, there are notes columns if needed. The reaction tab provides information and details about the exact reaction that was studied and which direction it was observed to proceed. This is a fairly complicated tab, and so we have a detailed video about how to fill out the reaction tab, which is linked on the screen right now. That's it for now. Thanks so much.